Okay, on the question about blood vessels within the kidney, many of you guys answered renal artery, but that's just this one. That's just the vessel going into the kidney. The question was asking about the vessel that was going to the afferent arteriole. So these here in italics refer to what's going on within a nephron. So I wanted to know the last of the main vessels that's leading up, which is this interlobular or cortical arteriole, leading up to the vessels within the nephron. And so the ones that you should have identified were listed as number 5. They're the little tiny lines that are radiating out here in the cortex. On another question, it had to do with the pyramids. So this here is a section where we actually have a pyramid is located in this portion because it's underneath this arcuate artery. And so up here is our cortex, and down here is our medulla. Now the pyramids are small sections within the medulla. However, the question was asking about the nephron parts. So we can see here's the glomerulus. We could see the blue proximal convoluted tubule and how the loop of Henle dips down, and then we go into the green distal convoluted tubule. So the part of the nephron that's actually in this pyramid is the loop of Henle. But I also included this collecting duct because it's in both. That is also in the pyramid. So we have the collecting tubule as well as the loop of Henle can be found within the pyramids of the medulla. So the point I've been trying to make over some of the questions is I want you to look at the gross anatomy here, and then I want you to be able to identify where nephron components are. So not only do the blood vessels where, say, we have our interlobar, let's change the color. We have the interlobar artery, and we have our arcuate artery, and then the interlobular or corticals. But I'd like you to also know about the nephron. So it goes into the glomerulus, and we have the proximal convoluted tubule, and we dip down into the loop of Henle, and we have a distal convoluted tubule, and then collecting ducts come down, and obviously collecting ducts converge to this papilla. But it's trying to overlay what's going on with the individual nephron. Again, we have glomerulus, here's our Bowman's capsule, proximal convoluted tubule, loop of Henle, distal, so this is then we have our collecting ducts. So if we have this where we're saying this here is the border between the medulla and the cortex, we can see that all the proximal convoluted tubule and the distal convoluted tubule and that renal corpuscle are all going to be up here in the cortex. Whereas the stuff down here, our loop of Henle and collecting duct, are going to be down here within the pyramids. So then there was other questions that had to do with different sections of the nephron. So if we'll just go through these sections just bit by bit. So in this initial portion, where we're just talking about the renal corpuscle, we actually know filtration occurs here. So the second portion is our proximal convoluted tubule. This is where the majority of reabsorption. But let's get into the nitty-gritty of cells. We also have the, we'll say simple, cuboidal epithelial cells. And what's more important, because the majority of fluid is reabsorbed here, those simple cuboidal cells are going to have microvilli, which increase surface area. So that's an important thing. So if you know that this section here has simple cuboidal epithelial cells with microvilli. When we get into the distal, it will also have simple cuboidal cells, but it will not have the microvilli because there's so little fluid by that point that you don't need the increased surface area. So let's go on to the next portion. So this next part, we'll talk about the loop of Henle. In here, you can see that there's this very slender descending limb, and that's also going to have our simple squamous epithelial cells. And then we have our thicker ascending limb, and this is where we'll have our simple cuboidal, because that's where the pumping is going to take place, where the simple squamous is where the diffusion is going to take place. So we have here descending limb, simple squamous cells. They're flat, ideal for diffusion. And then we have the ascending limbs, cuboidal, because they're thicker and ideal for pumping. Finally, the distal convoluted tubule, we also again have our simple cuboidal epithelial cells and no microvilli. Because as I said, there's less fluid by that time that we really don't need the increased surface area. Just the surface of the simple cuboidal cells themselves are sufficient to allow for filtration or secretion, or sorry, not filtration, to allow for reabsorption. We got reabsorption or secretion. Now remember, that was another question on the homework as well. Secretion means it's going from the blood into the tubule. That would be secretion. But reabsorption is going from the tubule and out to the blood. So you want to be very clear on the terms where secretion means going into the tubule, where reabsorption means it's going out of the tubule but back to the blood. In addition, this section, the distal convoluted tubule, is the area that hormones target. So there was a question on the homework about aldosterone. This is the area aldosterone is going to target, atrial natriuretic peptide or factor, as well as antidiuretic hormone. Those are the three that we talked about targeting this specific region of the nephron.